Right, okay, so this cone program that we had to write, we needed to accept the height and radius, and we wanted to calculate, was it the surface area and the volume or something, wasn't it? Calculate surface area, calculate volume. Right, now what you'll find, if you get a problem like this in an exam, they've actually, if you think about it logically, they've already started decomposing the problem for you. Can you see that they've split, the bullet pointed it to say what the specification for the program is? Well, actually, that's the breakdown as well. So I've got a calculation bit, so I've got to get my inputs. I've got to calculate the area. I'm just simplifying it for me. And I've got to calculate the volume. Okay, so this is based on a formula. Did anyone look up what the surface area of a cone was? What was the formula for it?
Oh yes.
What was it? Is that the surface area? Right. Pi r times what?
Times brackets r plus
The square
square
root.
root of h squared plus r squared. Yeah, I'm pretty sure.
Yeah, does that look reasonable? Yeah. Right. What was the volume? Which has probably got some sort of third in it or something.
No, it's pi r squared.
Yeah.
And then a fraction where it's got pi divided by 3.
It's simpler than the area, isn't it? Obviously, just
It's the height of
pi r squared times the height over 3.
Yeah.
I knew it was thirds of something. Because of the shape of it, you can guess it's going to be like something like that. Right, okay, so the physical calculations are just formulas. Now you can see that there is some values that we need to know. So if we was going to tackle this, we need to know what pi is. How to do pi in whatever language we're doing. If you ever get stuck and you just want to get something working to test that the logic's correct, you can always simulate pi and put something like that, 1419, or 142 if you want. So you can always approximate it. That'll give you roughly a decent-ish value for pi. Okay, so you can see that the only information we need is that radius and height. And then for the volume it's the same. Okay, so the crucial bit is doing the input. So getting the height, and getting the radius. There isn't much else to this program, but you can see we've got it broken down into 3 elements. So a bit of input, and then something to do the output, and something for the area, and something to do the output for the volume. Do the calculations. Okay, right. So what I'm going to do, this should be a function. So I'm going to create this as a function, and I'm going to create this as a function. Okay? That just does those calculations. How I format that final output, that's up to me. Alright? So, go into my code for Python. I can start framing this. So, I'm going to start first of all by just creating those 2 functions. So, remember, to create a function, we put def and then the name. So I'm going to put surface area. Now we said that the surface area needs the radius and the height. So I'm going to put parameters. I'm going to call them R and H because it'll make my formula look easier. So I'm just going to do that. A function returns an answer. So I'm going to say return. I'm going to say answer, or I'm going to say, what should I call it? Area equals, and then I'm just going to put a dummy in for now. I'm just going to say 1. Oops, I'm doing C#. And then I'm going to say return the area. So that isn't the correct code, but what I'm doing is I'm putting a structure down that I can then come back to and say, right, let's just work on the surface area. I'm going to do the same for the volume. So when you're coding, your live coding, this is something that you can do dead easy. You can say, right, I know what the structure needs to be, but I don't actually know what all the code's going to be yet. But I'm not bothered about that. I'm just going to put the basic structure in. So I know I need to calculate I need the radius and the height again. So again, I'm probably going to call that vol. I'm just going to put a dummy in and then say return the volume. So I'm going to replace that area equals 1 with the formula in a minute. Okay, but I've got to look a few things up. Right, so I need to do some input code. So I need to get the user to give me their height and their radius. So let's just do the height first. So I need to store that in a variable. I need to give it a sensible name, which I might call height. And then I'm going to input this, but this might be a fractional number. So I need to do a float, like you say. So I need to say float and then do input. And I'm going to make sure I let the user know what I want them to input. So I'm going to say gears height. So that does the height. Yes. It converts text into a number with a fraction. So if I put 10.5, which would be the characters 1, 0, dot, and 5, it turns that into a number 10.5. Okay. All right. Doing these things is what's going to be the key thing to nailing it all down. Right, so I'm going to do the same for the radius, because it might be 1.25, I don't know. So I'm going to call it radius. Sensible names matter. Again, I'm going to use float to take the input and convert it into a real number. Okay? Right, so I've done those two bits. Now what I can then do is I can format my output. So I can say print, and I haven't got any code yet, but I can say print surface area is, and then I can use that concatenation that we talked about last time, where we join text and things together. I can say join together whatever the surface area is. So I'm going to say string. Hang on, let me get rid of this so I've got a bit more screen space. Right, so I haven't written the code for it yet, but I've got a routine. Right, gents, if you're not watching what I'm doing, then I'm wasting my time. It's literally wasting my time. Right, so this is a number. This is going to be like a number. It's definitely going to have some fraction bits. It's got pi in there and everything. Right. I can say, given the radius and the height, let me just maximize this. So if I give it the radius value, which I've got stored in radius, and I give it the height value, which is in height. Now, why am I using str? Yeah, because I want to join two bits of text together, but the thing that surface area is calculating is a number. Okay? So I need to say turn it into a string. If I don't, Python will moan at me. It'll say, well, let me just try it. I'll just make sure that's... Look, there's loads of brackets there, but you can see that they match. So I've got a bracket for the print, which is the closing bracket. I've got a bracket round all this, where I put the string. And then I've got a bracket for the parameters for the surface area bit. Okay, so lots of brackets there to match up. There should always be the same number opening and closing. Right, if I run this, I should get the answer 1, because that's what I put in. Alright, so let's just run it. Right, so hang on, it's right down at the bottom, it's asking giz height. So I don't know what the answer, so 10 and 5. Oh, surface area is 1. So it's worked. Now what I've effectively done is a process called unit test. I've not actually tested that the area is correctly calculated, but I've tested that I'm outputting a surface area. I know the answer is 1 because that's what I've forced it to be. Now I need to know how to do that horrible complicated expression, pi times r, and then in brackets, and we've got to do square root as well. Okay, so I could work out how to write square root, but there's already a library for that. I think it's the math library in Python. Yeah, so I need to do an input. Is it? Can you just put math directly? Okay. Yeah, you've got to do your input first, haven't you? So it's the math module. Okay, so someone else has already bothered to write square root and to do pi. Alright, so what I can now do is I can attempt to do this hideous thing. So there's multiple parts to this. So there's a pi times the radius. So I'm going to do that bit first. So I'm going to say math.pi, and you see that that's telling me that's a float, which is good. So I want to times that by r. And I just put asterisk r. Right, so the next bit of that equation was the whole thing in brackets. And again, I can do brackets when I'm programming, so I can just say, and actually what that means is times, doesn't it? In maths we tend to not write times, we just stuff things together, don't we? We say AB, we mean A times B. So I mean times whatever's in that bracket. So I'm going to say times, and then I'm going to put a set of brackets. And then I've got R plus, so I'm going to say R plus, and then we've got this square root thing. So I'm hoping there is something called square root. Ah, there you go, square root. They always shorten it to SQRT because people are lazy. So we're going to have square root, and it just said, what do you want to square root? Now if we look back at our equation, it was h squared plus r squared. How do we get h squared from h? Yeah, h times h. So that's actually quite nice and easy to do. So I want h times h plus, and it was r squared, wasn't it? Plus r times r. Do I need to put that bit in brackets? Yeah?
Okay, I have a question. See, instead of doing h times a, why don't you do h asterisk asterisk and then 2? So it'll be like some half, so like multiplying.
Well, yeah, in Python there are facilities to do power of, alright? But what I'm trying to do is genericize it a little bit. So I'm trying to like think ahead for if we wanted to do this in another language as well. But you're right, Python has actually got that operator, multiply and multiply. In some languages it's this. You might put something like this. The hat operator. Okay, but yeah, I think Python does have that as well. But I'm just keeping it straightforward. Right, so I've got h times h plus r times r. Do I need to put that in brackets, or why have some people said no? Yeah, the multipliers will happen before the plus, won't they? Yeah. So we don't need to do anything. So what we've done is we've taken that. So you should never be afraid of using complex formulas when we're programming, because it's just a matter of taking maths notation and turning it into something that we can understand as a bit of code. So I've duplicated that. Okay, so I'm saying multiply math.pi.r by all that. Right, I'm going to run it and test it to see if it works. Oh, did I get an error there? Oh no, I wasn't looking at the screen properly. Right, so put a height in 10, 5, and I get the answer 254 0.160184615763. How do I know that's right? I need to actually do it myself, don't I? But because we've got a computer, let's see if there is a surface area of cone calculator. I bet there is. Oh. There'll be online calculators this. Right, so I'm going to check. So with my one, I said height 10, radius 5. So let's just get this to check for me. So radius 5, height 10. 254.16. So it did work. You've always got to verify things. Okay, so now we've had success with that one. I'm going to have a go at doing the volume one, which was simpler, wasn't it? So the volume was just pi r squared times h over 3. Yeah, so hopefully, yeah, math pi again. So I'm going to say math.pi, oh, my short-term memory's so bad. Was it r squared? So r times r times h divided by 3. Yeah, it was r squared. Yeah, pi r squared h3. Right, now, do we need brackets? What, to make sure that this bit happens first?
Yeah.
Now, well, we can try it, see if it makes a difference. So let me do my output for it. So print volume is, then use me concatenation again, string, so it's volume, radius and height. Okay, so hopefully when I run this now, but we'll check. Oh, just run. Thank you. I'll use 10 and 5 again. Right, so it says volume is 261. So let's see if we can find a checker for this. Oh, volume. What is a volume of a cone? Right. I'll tell you a really good site in a sec that does a lot of this sort of things. Right, so volume of a cone, so I said radius 5, height 10, 261. Ooh, that's interesting. I think that's what I got. Yeah, I got 261. Right, let's check to see if we need that bracket round there. In general, if you've got loads of multipliers, what order do you do them?
From left to right.
Yeah, from left to right.
Oh.
So let's just see if that even actually matters.
Yeah.
So I'm going to run it again. So, go down here. So 10 and 5, doesn't matter. Doesn't matter in that case because division and multiplication go together. Alright, they're the same.
We're going to do it anyway because I'm going to forget doing it in the other ones.
Right. In an exam situation, if you're doing an expression, sometimes you might put things in brackets just to make it clearer to yourself anyway, even if they're not needed. The computer doesn't use brackets, it gets rid of them. Okay? So yeah, if you just want it for clarity, there's nothing to stop me of doing that. It doesn't really matter. If it makes it clearer for you, but you start getting too many brackets, yeah. We try and minimise the number of brackets because it can like go, whoa. It can start getting not good. Okay, so we have to do the bracket there because we've got a plus. We want to make sure we add them before we do the final multiplier. Right. But can you see what I've done there, gents? The key to tackling this problem was doing those two routines and not worrying about how they work, just getting them set up, a skeleton. So I said, right, they need a radius and a height, so we'll give those as parameters. We kept those just as single letters to make the equation nice and compact. If I'd have called those radius and height, this would be huge. Alright? So, but that doesn't matter inside a function, because the function's just temporarily calculating something for me. And then I return the answer. Anyone got any queries about that? Right, I'll leave that up on the board. Get your one finished and completed. Okay? Help each other, but I'll leave that as is on the board. I'll paste it into the class as well.
Definitely on purpose.
I don't know why I've got that.
I didn't say it. I didn't say it on purpose. It was just like wait, no, let me not log into this one. Don't log into the other one because I didn't.
What I'm trying to emphasise to you, ladies and gents, is the structure.